Hello everyone, my name is Yashasvi and today I'm going to present our project title Aragog, which is Advanced RAG Output Grading. So this project focuses on adapting Aragog, a framework designed to evaluate retrieval augmented generation or RAG with a special emphasis on this medical domain. In simple terms, think of Aragog as a teacher for AI systems. Whenever an AI generates a medical response, Aragog grades its answer, checking whether it is trustworthy, completeness, and useful. And this way, we don't always need human experts to verify every single response, making this process more reliable and scalable. So, if you go to understanding of base paper, this base paper introduced Aragog as a scalable and automated evaluation framework for AI systems that use RAG. So, if you ask why is this needed, medical RAG system pull knowledge from large medical databases to answer these questions, but these answers may sometimes be incomplete, irrelevant, or even hallucinated. So, meaning the AI makes up the information. Traditionally, doctors or medical experts manually review these outputs to check if they were correct, and it is expensive since the expert time is costly. It is time consuming because delaying feedback, and Aragog solves these issues by automating evaluation with three matrices, with its faithfulness, completeness, and relevance. So together, these matrices ensure that AI-generated healthcare responses are judged in a consistent, scalable, and cost-effective way, building trust in medical AI systems. So if we go to problem definition, the problem of our project addresses is very clear. This is crucial because in healthcare, even a small error can directly impact patients safely. If AI systems cannot be evaluated properly, doctors and patients will lose trust in them, slowing down their adaptation in real world hospitals and clinics. So, the core problem we are tackling is ensuring that AI generated responses are accurate, safe, and reliable. Accurate means based on facts, which is real, not hallucinated. And next, safe, avoiding misleading or harmful advice. And reliable means consistent across queries. So our goal is to reduce dependence on manual expert grading and move towards automated trustworthy evaluation. So if we go of our project, scope of our project is well defined and focused. We will build multiple RAG pipelines, including sentence window retrieval, hypothetical document embeddings, and LLM ranks. So you, it is also important to mention that what is out of scope. We are not building a full medical chatbot for deployment in hospitals. Instead, we are focusing strictly on evaluation benchmarking, which is which lays the foundation for safer medical AI in future. So, and our proposed solution is extend Aragog specifically for the medical domain using a multi-pipeline approach. So if you ask how it works, a medical question will be passed through multiple rack pipelines. Each pipeline will generate a response. Aragog then Aragog will then automatically evaluate these responses based on faithfulness, completeness, and relevance by these metrics. Finally, we compare results according. Uh, we complete these results across pipelines to identify the most reliable strategy. By the end of the project, we expect to identify which pipeline produces the most accurate and trustworthy answers and build a benchmark framework that researchers can use and contribute towards creating safe AI decision support tools that could one day assist doctors and patients. If you go to architecture, this is a simple basic architecture diagram. So our architecture can be explained in three main layers, which is input layer and multi-pipeline retrieval and generation layer and evaluation layer. So in input layer, this is where the user submits a medical query. For example, a doctor might ask, what are the latest treatment options for diabetes? So, and then if we go to multiple retrieval and generation layer, the query which is asked by user or doctor that is sent through the different pipelines such as sentence window retrieval, hide, and document summaries and read anchors. Each of these pipelines generates a slightly different answer. And if you go to evaluation layer, this is where Aragog comes in. It, it grades each generated answer using the three metrics, which is faithfulness, completeness, and relevance. Finally, the system compares all the evaluations and highlight the most reliable pipeline strategy. And if we go for closing, to summarize, our project is about adapting Aragog to evaluate medical rack systems. So in this milestone, we have introduced the problem, explain the base paper, define the scope, and outline for our proposed solution, and presented the system architecture. So in the next pipeline, we will implement the pipelines, run actual evaluations, and compare the performance. So this will give us valuable insights into which strategies are most effective for building safe and reliable medical AI. So thank you for your time and attention. Thank you.